lec-ancova. What is a covariate? It is another variable that could influence the dependent variable. So you need to, if you don't want to include that variable, um, you could control that particular variable in the analysis that is called ANCOVA. So utilizing same puppy love data that we played last time, we're going to add one more data to it. So you collected it and then you want to control that particular um, uh, data that influence dependent variable. So here is the thing that look at the data here. You see the 30 people, participants total, three different conditions, control, 15 minutes and 30 minutes time with the puppy, and they wanted to look at dependent variable happiness of the participants. And then now the researchers think the people, their love of a puppy level could be different by individuals. So they measured how much each individual loves puppy, and they want to control that factor when they are looking at effect of puppy time dosage, control 15 minutes and 30 minutes on their reported happiness. So that's the data. And there are multiple steps to follow through. Always start with the step one assumptions and then learn 1A ANCOVA using GLM, then a post hoc test and determine effect size and then how to report. So ANCOVA video that you can watch posted there. Assumption test first, outliers and normality, linearity, and the homogeneity of regression slopes, then option one, option two. So you don't use Levins test here to test homogeneity in ANCOVA analysis. Then lastly, you test the independence of a covariates and treatment effect, and there should be no group differences in the covariate variable. Okay. So I'm going to go through step by step. I'm going to skip outlier normality test using Explorer since that's what you know already. And I'm going to go to linear test using linearity between dependent variable and covariate using chart build. So go to chart build and say OK here. And I'm going to reset here. So move scatter plot. First, scatter plot basic one and move happiness to x-axis, love a puppy to y-axis, and you paste it, okay, so that you have a program building. Then I just clicked it, okay, and then you will see there is a slight linearity, not that strong. So click twice, then it'll take you to chart editor. And then click add fit line so that you can see the trend of it. Then as you can see, regression line comes out, which is, this is a beta, regression beta is 0.23, 0.23 significant at 0.05, right? So there is a linearity. That's the first test that we just did. Close it. Then second one, now we need to test the homogeneity of regression slopes and option one. So option one, analyze graphics, chart build again, say okay, and then reset. So we can start all over again, scatter plot. Move this into here. All right. So now I'm going to put love of a puppy on x-axis. Then y-axis will be happiness, which is dependent variable. Then I want to look at this one by group. So put them on set color. right? Then paste it. Then this is what you're going to see. You can see the trend by groups, control group 15 minutes and 30 minutes. Click twice so that you can go to chart editor, then ask to put video line of all subgroups. So click that, then you will see the linear relationships between love of a puppy and happiness by group. By concept, these three fitted lines supposed to be independent. So which means they should not cross. If they interact like that, that means the homogeneity of regression slope is the homogeneity has been violated. However, depending on certain data, crossing interaction between these two groups could be okay because the research assumption is saying that 50 minutes to 30 minutes may have a positive relationship, but control group should not have positive relationship between happiness and a love of a puppy. And if that's the expectation by the researcher, having interaction between these three lines, regression lines, uh, is acceptable. So because of that little conflicting suggestion, theoretically they should be independent, but certain times interaction between those are okay. There is a second option that you want to test. So second option is looking at interaction effects between um, between covariate and IV independent variable. How do we do that? So this is option, second option to test the homogeneity of regression slopes, okay? So go to analyze and the GRM, univariate, I'm gonna just reset here. Put dependent, move dependent variable to under dependent variable, then those to fixed, and a love of a pathways, which is covariate to a fixed value, and go to model. And I want to build the model just to look at the interaction. So those and then hold shift button, right? Then both highlighted and I move to the model, then do you see that it created interaction effect there? Continue, and you don't need anything else. We want to look at whether that interaction is um, significant on dependent variable. So you just paste it to build your syntax file, and then now I'm saying okay, and I am particularly interested in this ANOVA table here. Dose and a puppy love, as you can see, was not significant. So homogeneity met. All right. Then last one in the assumption test was independence of covariate and treatment effect. You can measure that using GLM again and univariate, reset here, move those of puppy, of course, fixed, and then not happiness, covariate to independent variable so that we can see whether those of puppies are different in the level of puppy, like love of the puppies, okay? So then you don't have anything else here. I just want to look at the group differences for the assumption test. You paste, I say okay, and I am interested in this table. When I looked at those differences, three group differences on love of puppy, which is our covariate, look, not different, right? So that's the way to test all these assumptions. So we tested outlier normality by group and do it, run it. And then when I looked at it, it was not that big deal. And linearity exists when we looked at, although it was very weak by the regression slope. But regression exists, the linearity exists, and then homogeneity regression slope. When we looked at using first option, which is a common one, it looked different but it was acceptable level for the type of our data. But if you still doubt that, I want to double check, then go with option 2 so that you can look at interaction between variable covariate and independent variable on the dependent variable, which we did. It was acceptable. That independence was also supported when we learned the group differences on the covariate variable. Okay, so now we are going to move to this is all the procedures that what I just did. And then step 2, we're going to run ANCOVA and the postdoc and effect size so that we can learn how to report. So now ANCOVA. Go to analyze, GRM, univariate. Then I'm going to reset here. Of course, now is real analysis. So move dose of a puppy to fixed. If you believe it can be expanded beyond your sample and conditions, of course, you can use a random effect. Then and now, happiness, which is our independent variable, move to dependent variable, which is happiness, our dependent variable, move to dependent variable. Now truly move what? Love of a puppy to covariate. So when I move this one, I want you to pay attention to the options here, okay? As soon as I move love of a puppy under covariate, and you will see post hoc option grays out, not available. Look, the reason is a post hoc test, the way that it calculate it and then output, those post hocs are not valid statistically to interpret the post hoc test. So they just disable it so that you can go with other options. And what are other options? And then I'll show you how to do post hoc, okay? So model, we don't have much thing to touch here because it's one way. If it's two ways, of course, we could use it. Contrast, the planned contrast is the one that we will use, okay? So those, then which one we use? We can use a simple, we can use a repeated, we can use a hermit, depending on what combination would you want to look at. All those combination planned one already is available on one of our lecture slides, summarize how they look, which is also available in the textbook. So I'm going to just go with a simple one using first, which means number 1, 2, 3, we named it, right? So if we say first, then it uses a control group as a reference and compare to it. If I say last, then which is what is our last group, which is 30 minutes, right? Then 30 minutes is used as a reference. So I'm going to use first, then say change. You have to click this change. Then you will see change it here, then continue. Then in terms of a plot, yes, we want to look at that changes, right? So I want to see those and then move it. And then bar chart and include error bar, confidence interval 95. Continue. Then EM means it really give us, it's important because particularly when you use ANCOVA, you are going to report this mean score, not the regular mean score. This is more accurate because it removed the effect of a covariates. Then by default, it also creates a pairwise comparison, which we're not going to look at it here, but we need more adjusted, robust confidence interval. So that's what we are requesting using Bumferoni, and say continue. And then save. We don't have much that we are going to click here. We are not looking at it. And options, then now we are going to ask effect, descriptive stats, effect size, parameter estimate is the one to give you another post hoc test. Okay, then like I said earlier, do not run homogeneity test. All right, and then we could click this or leave it as default. All right, so in the example that I gave you in the lecture slide, I clicked it and then clicked the number 4. You don't have to really worry about this. However, if you want to advance your stats, this is to this is the area that you may want to look into. Okay, so I'm going to say continue here. Then I'm not doing bootstrapping, but again, bootstrapping could help you with the homogeneity, violated data. This is the current data that we have do not have the problem. And also bootstrapping gives you what? Robust confidence interval. Then you paste it. I'm going to say, okay, then the results came out. Here, between subject factor, how many members we have here, descriptive stats, happiness, and a regular one. Okay, but ANCOVA, like I said, you will report estimated marginal means, which is right here with the confidence interval and adjusted using Bonferroni because that's what we clicked. So report this um, mean scores, which is adjusted also for what? Covariate effects. So that's more accurate to report your mean scores, okay? So mean score report descriptive, use estimated marginal means instead of regular mean score and standard deviations. All right, here. This is ANOVA table. It doesn't say ANOVA. So ANCOVA table, you will see puppy love came out significant, which you need to report. Covariate was significant. There was group differences, significant group differences between control 50 minutes and 30 minutes, as you can see. And a parameter estimate that we asked in the analysis, and it used number 3, which is 30 minutes as a reference. That's why it's 0 compared to 2, compared to 1, and t-values and significance. And you report this in your description. I have some example how to report this table on the lecture slide. You could report post-hoc using this custom hypothesis test that we requested. Level 1 different to level 1, right? Level 3 different to compared to level 1, which is control group. And the 50 minutes group also significantly different, and significance is right here, and significance is right here. And with the confidence interval, these tools are also reported. And I made an example how to report this table in the lecture slide. Then yes, estimated marginal means, like I said, this is should be your descriptive statistic report table. It by default generate a pairwise comparison. However, looking at this table, which is planned contrast or parameter estimates are more accurate with ANCOVA. Then we requested results, right? The graph to demonstrate how they look different with the confidence interval, as you can see, control group 50 minutes and 30 minutes, and in the end, particularly 30 minutes are significantly different with control group. However, not quite with 15 minutes. And then that's the post-hoc test that we reported, okay? And then parameter estimate with the robust standard error came out because we clicked that HC 3 or 4 and we clicked the 4. This one, you use it to confirm the truth, the test output of regular regular parameter estimate came out here. This is not robust output. So if you want to confirm with the more strict statistical test, and then this is the way to use it. This is robust standard error-based parameter estimate. Okay, that is it. Then I want you to go over lecture slide where it has all the details of information. One thing that I want to show you before I close down. Here, this is part of our lecture slide. You have a data set, and when you run the data without covariate, there was no dose differences. Do you see that? P-value. However, when you used covariate, because there is a reason, I mean, you measured it. then you want to control that data within the analysis and then include that covariate in the analysis. And then Puppy Love took some of what unexplained variance and then helping the dose differences come out. All right, so that's why really always as a researcher is thinking about the potential covariate and collect them and control them when you're analyzing it. And it really help you to look at true group differences on your dependent variable.